All right, so what we're going to look at next are polar coordinates. Polar coordinates are basically an alternative way to plot a point on a plane. Okay, what we're used to doing is rectangular coordinates. That would be the x and the y coordinates. And we call those rectangular coordinates because when you plot those points, you would move left, right, and then up, down. And the transition between left, right, and up, down would be a perpendicular, hence rectangular. All right, so this is an alternative way to plotting xy coordinates. And here's how it works. The position of a point P on a plane, so on a flat surface here, can be described by giving the distance r. The distance r from a fixed point called O, sort of like the origin, except that we're going to call it the pole. We describe it by giving the distance that it is from point O, and by using the measure of the angle formed by ray OP and a reference ray, which we call the polar axis. All right, so let's draw some connections between that and the rectangular system. Point O, the pole, is pretty much the origin. That's what it is. You can think of this right here, the polar axis, as being the positive x-axis. Okay, and the negative x-axis would go that way. Y-axis would go up and down. So think about this being on top of that rectangular coordinate system. All right, now to describe P, instead of giving a negative x value and then a positive y value to get to here, what we could do is say point P is a certain distance away from O. Call it r. Radius is what we're kind of referring to here, though. Okay, describe it as a certain distance away, and then provide a direction by using theta. Okay, and theta is going to be measured from the positive x-axis side. We call it the polar axis here, but just think of it as the positive x-axis. As an example, over here, we've got this point located. The way that we could describe it from that polar axis, the measurement of the angle is pi over 3, which is the same thing as 60 degrees. Okay, so you'll see it in both ways here. All right, so we measure out a certain angle that we have, and then from O, we're going to measure out a distance, whatever that radius would be. This example, that would be 4. Okay, what the actual units are, I'm not quite sure, but whatever those units would be, it would be worth 4 out in that direction. Similar to how we describe coordinates in the rectangular system, we do have two values. So in the rectangular system, we've got x's and y's. For the polar system, we have an r and a theta. We have an r and a theta that we use. Now, weird thing that I always think about this when I do graph is that when I plot the polar coordinates, I tend to start with a theta. So I actually start with the second value. I figure out the direction, and then after that, I'll figure out my distance and plot my points. All right, but we will write our polar coordinates in parentheses, just like we would with our x's and y's. All right, so what we're going to do for example 1 is graph a couple of points using polar coordinates. Okay, and I'm going to go ahead and do these. I'll do these on the same system. All right, now when I set this up, you wouldn't have to draw this. So I'm going to do it as a dashed line, but I'm going to think of it as if I have this y-axis that would exist, okay? And there's an x-axis. However, we're really supposed to just be looking at the what we call the polar axis. It would be here, and then this would be the pole. And we call it O because it's like an origin. I want to keep it there. All right, so our first point, it's going to be at 20 degrees, a distance of 5, and I'm going to measure that in centimeters, just so that I have some units to scale things with here. Okay, so I'm going to start with the angle. Start with the angle part. We'll do this, that'll be in red. All right, so set up the protractor. Here's 20 degrees. So that is going to give me a direction. Okay, it's going to go in that direction. The distance out is going to be 5 centimeters. So pretty close to that dot that I already had, but it is actually here. Okay, and we don't need to draw a segment out to that spot. This is just it. That is the location of it. That would be point P. All right, but for the sake of, just for the sake of being able to look back at this, I'll go ahead and connect it, and I'll write down the values we had. So that was 5 centimeters. And that was 20 degrees. That's how we got that one. All right, for Q, we'll do that in blue. -3. We'll talk about that in just a moment here. 50 degrees, protractor. 50 degrees. Okay, so here's 50, so I'll put a little dot there. All right, now if that were a positive 3, what I would do with that is I would line this up and I would put a dot right there. That's what I would do because that would be 3. Now, since I got a negative 3, what it tells me is I got to go in the opposite direction. I have to go in the opposite direction. So this sort of set me up as far as the angle that I go at, but being that that's negative, I'm going to need to go backwards, which will put me in quadrant 3. Okay, so I'm going to line things up. I'm going to do it like this. I'm going to line it up that way and put 6, just choosing any whole value there. Put that there. So I'm lined up to 50 degrees. What do we got to do? We got to go 3, so that'll put us right there. Here, I'll actually draw the line. So that'll be that. Let's put a dashed one here. See if that looks good. Okay. So that measurement, that is 50 degrees, but because we had a negative 3, we actually end up way over here. There's Q. All right, now what is true, and I hope you make this observation, that this is also 50 degrees. That's not where you begin with the problem. What you should do is draw your 50 degrees or measure 50 degrees and then just work backwards. But there's these neat observations that we could pick up on. All right, so what we have next is really the main thing that you need to be able to do, which is convert back and forth between polar coordinates and rectangular coordinates. Because remember, these can be on the plane together. Okay, so if we switch the type of plane that we have, we should be able to give a location for any point in either rectangular or polar form. We should be able to do that. All right, so first let's just talk about like a point in general that would be out there. Okay, so we got this point. Let's just call it P. I don't think that's too important, but we're gonna call it point P. And point P, the way that it's been drawn so far, it seems as though we've identified the radius and the theta because we're measuring straight out to that point. Okay, so this has a distance of r, and this would have a measurement of theta. We'd have that one. All right, so what about the rectangular coordinates, the ones you've been using forever? Okay, to get out to point P, what you would need to do is move from the origin out to the right and then up. Okay, so what I'm gonna do is draw these extra lines. Okay, that would be a y direction, a y amount. This would be the x. Okay, so in rectangular form, to get to P, you would go over x and then up y. That's how you do that. All right, so now how do I convert? How do I take, if I had the x and the y and I knew that I needed to go out and then up a certain amount, how do I take those values and figure out what the radius and the theta would be? Okay, well the radius, this is a right triangle. The radius you could get using Pythagorean theorem. The r value would be equal to, actually, I'll do it this way. We got x squared plus y squared. Okay, it'd start like that. Now r does not equal x squared plus y squared. It'd be r squared is equal to those things. So if we do a square root, that would give you the value of r. That would give you that. All right, so for theta, to get that using just what we have here, to get that, we can do an arctangent. Theta is equal to the arctangent of the y value divided by the x. All right, so I'm gonna go over that one more time here, that if we have an x and a y, and that's all we've got to work with, to figure out the r value, which we can also call the radius, the r value or the theta, to do that, these are your calculations. You do Pythagorean theorem with the x and the y to get the r value. You can do an arctangent with the x and the y to get the theta. All right, now let's look at it from the opposite direction. What if we had these values? You had the radius and you had theta. How would we figure out what the x and the y would be? Okay, so let's think of it this way. I'm interested in figuring out the x. I want to know what the x is, and here's what I have to work with. So I'm going to build a relationship between these three things here. Now remember, this is a right triangle. Okay, so theta, with respect to theta, this would be the adjacent side, this would be the hypotenuse. Okay, so I can actually build a certain equation. Let me write it over here. The cosine of theta, remember cosine is adjacent over hypotenuse, the cosine of theta would have to be equal to the x value divided by the r value. So now, what I'm really trying to do though is solve for x. I want to know what x is using these two things. So real quick solving, I could multiply by r, cancels out, and now I have a formula for x. I can say that x is equal to r times cosine theta. So I'm using just the two things I would have from the polar coordinate to get the value of x. All right, now pretty similar for y. What we can do here, the y is not the adjacent, it's the opposite. Okay, so the sine of theta would be equal to the y value divided by the r value. Then solve by multiplying by r. We do that, would be equal to r times sine theta. All right, so y would be equal to r times sine theta. All right, so let's go ahead and apply these conversions here. For example 2, we're going to give the polar coordinates for a rectangular coordinate, so that'd be an x and y. That would be 3, 4, and theta is going to be in degrees. We're going to make sure it's in degrees for this problem. All right, so we do have the formulas, but might not be a bad idea, just at least while we're getting started with these things, to go ahead and draw like a quick picture. So 3, 4, that would just be in quadrant 1. Pretty simple idea there. All right, so it goes out 3 and then up 4. We'll just estimate. We'll estimate it. All right, so 3 and 4. Okay, so again, we have the formulas. We don't really have to draw the picture, but you know, there's nothing wrong with actually doing that. So the r value would be right here, okay, and we can just use Pythagorean theorem to get that. We'll take, now you should recognize this as a triple. The answer is going to be 5, but you could do 3 squared plus 4 squared. You can get 9 plus 16, which would be 25, and then the square root will give you 5. Go ahead and make a little box for our answer right now. Radius is 5, we got that one. All right, and then to get the angle measurement, which would be here, what we'll do is an arctangent. Okay, we're going to take an arctangent of the opposite side, 4, divided by the adjacent, 3. All right, so with the calculator set to degrees, we'll do an arctangent of 4/3. That gives us 53.1. And that's it. That's all you really got to do to convert rectangular form into polar form. All right, for example 3, we're going to give the rectangular coordinates for polar coordinate that we have over there. So again, maybe drawing a picture wouldn't be too bad of an idea. All right, let's think about this angle though. First, we got 2 pi over 3. We got 2 pi over 3, so that would actually convert into 120 degrees. All right, so 120 degrees, it's going to put us, we're going to estimate here. So thinking of that pi over 3 is 60-degree increments. You'd have 60, which is most of the way up here. So 60 is going to be most of the way that direction. So again, it doesn't need to be perfect, but we'll aim for it. We'll aim for what we can. All right, so this is going to be 2 pi over 3. That's 2 pi over 3, which means that right here, we've actually got just pi over 3. We'll add that in there. Let's just put a little dot there for a point. All right, so what else do we know? We know the radius, that would be 3. All right, and what we need to figure out, here is that height and this distance. That's what we want. So a little coordinate, there's a box. Let's get it ready. All right, so to do that, the formulas that we have, we're going to apply those directly. We don't want to redevelop this whole thing, sort of like I was able to do in the above problem with the Pythagorean theorem. Okay, so the x is going to be equal to the radius, or the r value, multiplied by the cosine of the angle that we have. Now, we could just use that angle. You could use that one. So if you're typing it into the calculator, you could go ahead and just type that number in there. And the cool thing about it is that it's going to recognize, using that angle measurement, that we're in quadrant 2, and you're going to get back a negative number. Okay, that would be a negative x that we'd have here. This would be a positive y value. All right, so we could just go ahead and type that in. In fact, I'll just do that way. I forgot to write theta down in that spot there. All right, so let's just type it in. Let's do 3 cosine theta. Let's just do it. 3 cosine. I do have this set to degrees, so I can convert on my own, or what I would do is just make sure I change it into radians. So 2 pi divided by 3. We get our value, so that is actually going to be negative 1.5. Okay, and you're going to notice that using that angle, we actually get our negative that's here. All right, so for the other one, pretty much the same thing. I can actually just copy what I had, but switch that out for a sine. I just switch that out, and I get 2.59. So not as pretty, would not be as pretty. Actually, it's about 2.6 would be a better way to call that. All right, and that's it. You can stick to that. Here, I'll go ahead and write this down here. All right, so for the x, it was actually 3 cosine of our angle. That would be your x value, and then for the y value, it's 3 sine of that angle. So what you might want to do here is just build an association that the y values will be assigned to the sine function. The x values are going to go along with the cosine function, and then other than that, they're pretty much the same thing.
Later, blah.